All right, so this problem, like most of them, you can begin with writing down your law of conservation of energy combined with the work energy transfer theorem. You want to begin with that. So just like a body at rest tends to remain at rest, I'm trying to get it so that you're not at rest to begin, you're at least getting started, because you can always start by writing this. KO plus UO plus W equals KF plus UF. So there's your equation. So the next thing after you have that done is you want to figure out what I can make zero. Usually something in these equations I can cancel out. So it says a boy is sledding down a hill that's 15 feet high. So, well, first of all, I can see that the units in this problem are English units. So you're not going to see this on the test. I'm not going to give you English units, but you should know how to do it. Everything is going to be the same other than the last step when you plug in the numbers. So they give you, it starts down a hill that's 15 feet high. Starting at the top, the person already has a speed at the top. So maybe you're running and jumping on your sled, and then you're going to go down the hill, so you're going to be moving at the top of the hill. Said the sled reaches the bottom with a speed of 25 feet per second. Now it says how much work was done on the boy and his sled if their combined mass is 8 slugs. Well, once I jump on the sled, the only work that really could be done on it, like a normal sled, is friction. So that work is probably going to be negative work. It's probably going to be a work meaning that if there was no friction, maybe I'd get down to the bottom of the hill at 35 feet per second or at 40 feet per second. The fact that I'm only getting down to the bottom of the hill at 25 means there was probably something that was hindering my movement down the hill. So once you have, really, there's nothing, the one thing that I can make zero is that when I get to the bottom of the hill, I'm going to have no potential energy. So I can at least make that zero. So the next thing, once you have that, is now you're going to replace KO with 1/2 MVO squared. I'm going to replace UO with MGHO. Now work can be replaced with force times distance, but I'm not going to replace it with force times distance because the unknown is the work. That's what we're looking for. So I'm going to leave it as a plus now, but if my answer comes out to be a negative, then I know it was negative work. So right now it's plus. And on the other side, I'm going to get 1/2 MVF squared. Now, since W is our unknown, there's a couple things we can do. I always tell you that when you're doing a problem and there's fractions, multiply by the least common denominator. So I can certainly just multiply every term here by 2, which is the least common denominator, and then move these two terms to the other side and divide by the 2 that would be right there. Or, since W is my unknown, and I'm not creating complex fractions by moving these 2 to the other side, I'm just going to move those 2 to the other side. So when I did this in class earlier, I didn't do that. I actually multiplied through by 2, but then somebody asked me, can I just move these to the other side even though there's a fraction? And you can in that example because, like I said, I will write lazy algebra on your test if you move things around and create complex fractions, like fractions inside fractions. I'm not going to be creating fractions inside fractions by simply moving these 2 to the other side. So I'm going to get W equals 1/2 MVF squared because that was already on the right side. And then I'm going to move this one over. So it's going to be minus 1/2 MVO squared. And then I'm going to move this. Oh, I'm sorry. Then I'm going to move this over. So it's going to be minus MGHO. So now you just plug in the numbers and you'll get the answer. Now, remember this is English units, so be careful. So I'm going to put 1/2 MVF squared minus 1/2 MVO squared minus MGHO H. And the mass is 8 slugs. So in every one of these, I'm going to put in 8 slugs. 8 slugs there, 8 slugs there, and 8 slugs there. And I probably should be writing 8.0, but my parentheses I made sort of small, so I want to be able to fit them in. My final velocity is over here. It went from 10 feet per second and reached the bottom at 25. So 25 is going to go right there. So I've got 25 feet per second. And over here, I have 10 feet per second. Now, here's where I've seen a lot of mistakes made when the problem is in English units. They know over here that this is MGH, and they make the mistake of putting G. We're used to putting what for G? 9.8, but this is the English system, so you're not going to put 9.8. You're going to put 32 feet per second squared, and then the height, the original height was 15 feet. Now, if you look at your units, I'm going to get for my answer, it's going to be foot-pounds, because a slug foot per second squared is a pound, and I have an extra foot up here. Same thing here. A slug foot per second squared with an extra foot is foot-pounds. So all three of these are going to be in foot-pounds. And if you solve this, the answer came out to be, minus 1.74 times 10 to the third foot-pounds. All right, any questions on that? You can see that there's not a lot of steps. I mean, you're going from your very basic conservation of energy equation to then replacing each of these with what they represent. UO is MGH, K is 1/2 mv squared, and then once I'm there, then it's just algebra. Then it's just rearranging the equation to solve for whatever the unknown is.